Alrighty, welcome back, everybody. Hopefully you had a good couple of days. Hopefully you're kind of getting into the groove of things. There was technical difficulties the other day, so that's how come you didn't see a live video post. Okay. We're gonna see if we got things fixed today. I mean, you're here, so that's great for you. So, but I'm trying to make it aware after today, all these videos are gonna post. We'll see. Yeah, everything's working, but we'll see how it works. Yeah. We're gonna see if I can't still load these live videos. For some reason, it wasn't working, but it will eventually. You'll at least get one video from me online. I guarantee that. Okay, so today we're gonna end up going through chapters 1, 2, 3, and 4. Sounds like a lot until you start realizing, oh crap, that's easy. Okay, it's like the easiest thing you're ever gonna do. Okay, these first two chapters are super easy. You're more getting a concept. Okay, of kind of what statistics is. And then we're gonna start doing like some preliminary math around chapter 3, 4, and 5. And then we're actually gonna do statistics in chapter 6 and beyond. Okay, so that's kind of how the things are gonna go. Just kind of not a warning, but as a reminder, please get into Hawks ASAP. The QR code should be working. I've heard nobody complain about it yet. I'll double check it today. But remember, after today, use the QR code or the activation link in the module to go ahead and check in for class. If you're late to class and the QR code isn't working, then you're going to come tell me after class that you were here and sign a little post-it note so I don't forget to put you. But I won't accept an email later. Okay? Good? All right, let's get started. Let's see how well everything's going to work today. Sure. Hit share and maybe I'm sharing now. Is everybody seeing things over in the Zoom area?
Yes, sir. Lovington sees it.
Do you see the PowerPoint?
Yes, sir.
Perfect. Thank you very much. I want to make sure everybody sees everything. Thank you very much. All righty. So data classification. It's going to be very weird for me not to go. I have to look over here. So data classification, what is it? That's going to be your 1.2. Okay. So basically, what is data and how do we classify it? Obviously, you should have been kind of already answering this in your discussion post. And I don't want the run-of-the-mill chat GPT. Whatever you think it is, tell me what it is. Some people say it's just a bunch of stuff. Okay. Some people say it's a collection of numbers. Some people say it's how statisticians do their stuff. You're all kind of right. Okay. I'm going to just arbitrarily, let's just call it information. Okay. So I can put here info. Okay. Now here's the problem with information is how do you decide to classify? Like if I'm studying age groups, that's one way to classify it. But what if I'm studying pain scale? Okay, I am a doctor and I'm studying, does this drug work on pain? Is it working? How do you decide, how do you quantify pain? The way I feel pain, obviously looking at me, I'm gonna feel pain a little bit differently than you do. Okay, I'm gonna classify it a little bit differently than you do. And so that's what we need to be aware of. And I say that because this. 1, 2, 1, 3, 1, 4, I'm basically, this is where I talk about, hey, this is kind of getting your feelers up. Whenever you hear something, I want you to always be able to go, I wonder. If you hear somebody say something on social media, I don't want you to go, that sounds legit. Does it? Did you ask a deeper question? You know, it's sort of like the old study that said, did you know that there's a study right now that says salt causes heart attacks? You know who paid for that study? The sugar company. Maybe consider something like that. Like, why would the sugar company be trying to go against the salt company? Maybe they want you to have more sugar, so it makes them look less bad. So that's the kind of things you gotta start thinking about, okay? So what we're gonna learn in this first lesson here is how to start classifying different types of data. Because some data or something you hear about that you put a lot of stock into, really, we're gonna say mathematically, is bunk. It means nothing. Okay. For example, look here. I've got two different types of data here. Okay. things are gonna be kind of lumped. Right now, we're gonna call it qualitative and quantitative. Right now, I'm using pictures. Obviously, qualitative, look, it's like films, pictures, letters. Really kind of just stuff. Notice it's a quality of stuff. Whereas if you look at the other little circle I got there, you got charts, mathematical operations, numbers, actual numbers, graphs, actual data, scientific type stuff, okay? So that would be more of a quantity. So that's one way to start kind of classifying data. That would be almost our first little, okay, we're gonna take all the data you talked about and we're gonna separate it, okay? Into two categories. It doesn't mean one is worse than the other. I don't want you to start sitting here and leave class today and going, oh, well, Amazon reviews, or they don't mean anything. That's partially correct, but if I'm going to buy like a shirt and it's got only 1 stars, I'm probably not gonna buy the shirt. Whereas that type of data is still not really great, I'm still gonna be like, I'm gonna trust that 1 star. That kind of help you out just a little bit. So I don't want you to walk out of here, I want you to walk out of class being informed, but not a conspiracy theorist, okay? So qualitative, that's the first thing. Categorical data, qualities, what does that mean? Labels or descriptions of traits. No math can be done. Everybody here has probably been to the hospital at some point in time or a doctor's office. You ever see that little pain scale, little happy faces? Well, how do you quantify that? Like, I get it. You're gonna go, well, it says 1 through 10. Okay, well, great. What does that mean? What is a 10? Well, what is that? I know my daughter, when she gets a splinter, it looks like it's a 10 for her. But then on the flip side, when she broke her arm literally in half, she didn't cry at all. Where's the 10 then? Do you notice how that pain scale just kind of just went out the window all of a sudden? It's like if a 10 is a splinter, how come a broken arm is more like a 6 if I had to kind of gauge it, you know? So you notice that one really, and I can't do any math. I mean, let's think about it. If I was a doctor, said, hey, how many people we come in today? We had 30 people. How many were at a 9? Okay, we had all of them coming in a 9, or the average was a 9. What does that really mean? Can you tell me what a pain scale of 9 really is? What that average would be? No, you notice how it doesn't really mean anything. No math can really be done to it. That's kind of what it's saying. Qualitative data, categorical, okay? It depends. Our book uses qualitative. The vernacular nowadays, in more recent terms, they say more categorical. Okay, those terms will be used interchangeably, not in this book, but if you're out there listening to something and you hear like some study, some YouTube or something say, the categorical data says, no, they're actually talking about qualitative data. Okay, or sorry, qualitative data. So, what do we got here? Notice, here you go, there's some types right there. Eye color. How you gonna do math on eye color? Can't really do it, can you? Religion. Everybody in here probably has a religion. Even if you don't have a religion, that's a religion. And every single person in here is going to say theirs is the best. If you're not saying yours is the best, then why are you going for that? Go for no. Okay, that makes sense, but you can't really do any math to it. I can count. I can say, hey, how many Christians are in the room? How many Muslims are in the room? That's not really math per se. Okay, recipes. Okay, teams. Team ratings. Some people are going to say, hey, my team's the best. What qualifies best? Well, they won this year. Won what? Well, they won this year. Does that make them the best this year or the best overall? Notice that rating, okay? There's a little pain scale to be happy, sad. And then, okay, hear me out. Birthdays, not age, birthdays, okay? Can't really do math to those. I can sort of go how many, there are, but I can't really do a lot of math to it. Quantitative data or quantity, what is that? Counts and measurements. Okay, that's pretty straightforward. I can do math to counts and measurements. Okay, you give me different distances, I can average them together and give you the average distance. You give me different speeds, I can do the same thing. Kind of straightforward, right? Temperatures, I can do the same thing with temperatures. I can do the same thing with money. Somebody has this much money in their account, I have this much money, we can start averaging money, we can see growth of money, spending of money, inflation, recession, all kinds of stuff with money. So math can be done. Some examples. Weights. Distance. Demographic areas. What's happening in this area? Square footage. Time, obviously. Age, notice the difference. I said 1, birthdays, but age, I can do math to. The average age of this class. Okay, is there an outlier? Me and her, not to throw you under the bus. Where would be the outliers? You know, we'd both be over here. Somebody here is probably gonna be really young. You might pull everything this way, okay? So, money, and then once again, like I said, money. Am I going okay? They kind of keeping up? We done math yet? Welcome to math class. See how I did so far. Now, inside that data, okay, we have discrete data and continuous data. Okay? We are going to begin this class basically talking about discrete data. Okay? And then we're going to transition to continuous. Okay? Because in statistics, if I can find out about a little, I can tell you about a lot. Remember the whole thing where I said, hey, a person, me, I'm an individual. Okay? I am. I'm very unique. My wife will tell you that. She goes, the things that I'm into are just like, she goes, you are one of a kind. She goes, you're one of the few people I know at 1 o'clock in the morning, if I catch you on a video, it's not gonna be something bad, it's probably gonna be something mathy. Or so, who knows, you know? Not very many people stay up at night watching YouTube videos over math, for the fun of it, okay? But, having said that, take 1,000 of me, take 10,000 of me. You know, Caucasian, 45-year-old, master's educated, you know, homeowner. And there's gonna be a lot of commonalities. Just gonna happen, okay? So my uniqueness tends to go away. The more of me there are. Does that kind of make a little sense? So notice I went from discrete, countable, to continuous, okay? So discrete or continuous data, think of it this way, data that can take on any value, i.e. think of counts and measurements. Can I have different lengths? You know, if you don't believe that, go back to math class and think of pi. Pi is the ratio, right? And it never ends because it depends on your level of exactness. It depends on what number you're going to stop at. That would be continuous. Okay. Distances, even age is continuous data. Like right now, I'm 45, but really, let's be honest, am I exactly 45 years old? Yeah, like right now, I just got a little older, and now, and now. Notice, so it's a constant thing, okay? You can't really put it this age, so it can be continuous. Even money, if you're talking about large, maybe of a country, could technically be continuous because countries can print their own money. You can't, so yours would be very discrete. Okay. Discrete data, obviously data that can take on particular values, usually counts. Discrete data. Let's go back to Amazon, the stars. Could you count how many stars? Yeah, you can look at it and go, man, this basket or whatever, what's my wife buying now? Vitamins. She's buying a lot of vitamins. We are vitamin happy at our house right now. We can look at the rating and go, oh, look, 30,000 people have bought this item. 20,000 have rated it or whatever. There you go. That's a count. That's discrete. I can see it. Okay. Now, once again, notice we started out quantitative, qualitative, discrete, continuous. Well, even inside these are levels. Okay. These levels look like that. Nominal being the lowest. This ratio, okay, being we're just going to call it the highest, okay, level. Now, I say that in full knowledge, I don't want you to think all nominal data is crap. Once again, Ladies, are you gonna buy makeup if it's got like only a half a star? From everybody? No, that's probably got some weird junk in it. Don't buy it. Okay? It's still nominal data, but it fits what they were trying to do. Okay? It'd be very weird to be trying to sell you makeup showing you math equations. You'd probably never buy my makeup if I was trying to sell it to you like that. So some things fit whatever we're trying to study. It just depends. But I also don't want to give you a drug study going, hey, how will this drug study work? 5 stars. No, did it cure me? That's what I want to know, bro. Show me the math. Okay, is this thing gonna work? Notice the different levels there. Okay. Good news. There you go. Qualitative data will fit with inside nominal and ordinal. Okay. Why? It's qualities. Okay. Can't really do math to that kind of stuff. Okay. Well, that means the other one, quantitative, quantity. Okay. So the bottom two, okay, are going to be the qualitative. Top two, interval and ratio, are going to be quantitative. Okay. Don't stress out too hard on these definitions. I don't want you to start thinking right now, man, are we gonna be doing this the whole time in class? First chapter. Okay, just so you kind of get your feet wet on like when you start reading stuff later on. I promise you, you're not gonna believe me, but let me just give you a warning. You are now living, and I'm gonna say this unfortunately, in a data-driven world. Every job out there, I don't care if it's from McDonald's to being a lawyer. Everything now is data-driven. Everything now is going AI. Everything now is being ran by statistics. And the people that kind of know it, even if they walk in with a very rudimentary understanding of it, are going to have a leg up over the guy next to them. It's just going to happen. Okay? I know churches right now that are hiring statisticians so they can find out more about their congregation. Because, I mean, how do you know about people unless you know how to study them? And I'm going to show you shortly, it's harder than you think of going, well, I'll just ask a question. It's harder than that. Okay, it's really harder than that. Okay? So, what are we looking at? Nominal. Labels or names? Think about the happy, sad, right? Ordinal. Data can be arranged. Okay. Labels or names, let's be honest, that's sports teams if you kind of thought about it, right? To you, you could probably rate them, okay? Ordinal, data can be arranged in a meaningful order. Okay, once again, teams could fit there as well. Also, maybe anything, any sort of rating, maybe eye color, okay? Maybe like the number of eye colors, we could rate them in that way, like light absorption, who knows? But notice, it's really just a ranking system, okay? Any questions over that one? Pretty straightforward. Quantitative, interval. Okay, interval, I'm going to show you a ratio. They're pretty straightforward. It's very easy. I'm going to give you a little hint on how to know it's apart. Interval, data can be ordered like ordinal, so a ranking system, but, okay? Differences are meaningful, can include a 0 point, does not mean absence. What does that mean? Give me something. Where could you have 0, but it doesn't mean like it's gone?
Degrees.
There you go, degrees. Can you have 0 degrees? Does that mean no temperature? No, that just means it's 0 degrees. It doesn't mean a lack of temperature. It just means it's 0 degrees. Okay, that's what that means. Okay, so on the flip side of that, okay, ratio, same thing, ordered, meaningful, but 0 does indicate absence of something. I don't know, money. You can have no money. Okay. There you go. That does mean something. That 0 does stand for something at that point. Okay. And that's about it. There you go. That would be the end of the lesson. That's it. You just got to go through here now, and we'll go through very quickly. Then we'll get into the other lessons. I'm just going to do a couple here. And then, like I said, all the when you go into your notes, I have some homework questions kind of done up for you that you can look at and go, okay, I get it. Notice we still haven't done math yet. Okay, types of motorcycles in a showroom are an example of which type of data? Qualitative, extreme, parameter, or quantitative? Is it?
Qualitative.
Yeah, why?
Because it's types of motorcycles.
Yeah, it's types of motorcycles. How you gonna do math on that? Now, mind you, if I just said types, I just said types of motorcycle. I didn't say how many of. It also depends on how I ask the question, right? I said, hey, how many of this type of Indian? They'd be like, oh, now we gotta do some counting. But if I just said types, we don't have to worry about that. Okay, so yes, what y'all saying?
Qualitative.
Qualitative. Good rule of thumb, quality, just think quality. Okay, take it, don't think qualitative, big word. Nobody likes ugly math words. Qualities. Can I describe the quality of this data? Yes, there it is. Goals scored during a soccer game are an example of which type of data? Qualitative, quantitative, inferential, or statistic?
Quantitative.
Very good. Fine. It's a what? Quantity. I'm counting. Okay, so yeah. There you go. All right, so that was lesson 1, 2. Anybody have any questions? Thank you so far. Give me 1 second while I change slides. One second while I change over here real quick. There we go. Doesn't have audio and I want to make sure it works. All right, process of statistical study. Please, if you're not seeing it on Zoom, just let me know. If not, I'm just gonna go ahead and keep on at it. Okay, process of statistical study. Okay, unfortunately for you, or maybe fortunately for you, I don't know, they had fun with it last semester. Last semester, we did a statistical study. In my stats class. Everybody got to choose what they wanted to study. They found data. They ran experiments, not experiments, sorry, can't do experiments. You'll see why shortly. But they got to learn something. I had students do it over social media. I had one student do it over volleyball. It was actually very interesting what they found out, okay, on their own. Using the skills they learned in this class, okay? So how do we do a statistical study? Well, let's design the study. What that means is this. Here's what people do sometimes. They gather data. Get a whole bunch of data of something they want to know about. Maybe it's underwater basket weaving. Okay? And then after they get all that data, they learned everything, then they ask a question. Well, you've just done it backwards. Okay? You can't do that. You need to design the study first, okay? You'll see shortly. That means doing a bunch of things before we even get to the data collection, okay? State the question to be studied. How many students do I average have on cheating in this class? Maybe that's a study. Determine the population and the variables. Who's my population? My statistics class. Or my students as a whole, or NMJC students. Notice, I'm defining things first. Variables, how am I gonna see what affects you? You'll learn about variables shortly. Determine the type of study, okay? Is it gonna be observational or is it gonna be experimental? You'll find out what that is. Finally, we're collecting data, okay? Then we organize it, and then we analyze it. Believe it or not, usually the hardest part is the organization. Used to be anyway. Now we've got like Excel. They have a programming language called R. It does a lot of that. You literally hit a button. Next thing you know, tells you whatever you want to know. Matter of fact, even Excel now has incorporated the Python programming language into it. So you can run Python script in Excel, and it's amazing what Excel can do. Okay. And yes, I'm that kind of nerd. I love Excel. I love graphs. Told you, I was reading a book about graphs. So let's go through this. Observational study versus experiment. Observational study. Observes data that already exists. We measure or survey members of a sample without trying to affect them, okay? That happens a lot. Animals in their natural environment. Okay? Drinking tea before bed. Okay? literally, you might just go around and watch people, okay, and go, okay, what happens if they drink this tea? I'm not going to do anything to them. I just want to record what happens. Or whenever I release this elephant into a den of lions, what's gonna happen to the elephant? I just want to observe. I want to do nothing. Okay, and that was actually, I'm lying. That would actually be an experiment because I'm doing something. I want you to realize when you're doing observation, hands off. You're literally just along for the ride. Okay, whatever happens, happens. Okay. Social media use. I had a student last semester, his study was, is there any correlation between social media use in time and happiness? Okay, and he studied some people, he looked up studies, I mean, he really worked really hard on it. And he found for every hour that he saw people on and measured, their level of happiness went down by 20%. Okay, because they were living not in a normal way anymore. They were living outside of things. So is it correct? I don't know. I'm not gonna say it is, because that's one study. Okay, we'll talk about that shortly. Experimental. Generates data to help identify cause and effect relationships, i.e. vaccine study. Social media and happiness, I brought up his. Okay. Back roll. Experimental. I give you drug, do you get better? I tell you to use social media. Like I find somebody, like let's say she's never been on social media at all. And so I say, here, I want you to start using it. Then I start measuring. Notice now my hands are on. My hands are doing things. I'm nudging things a certain way to see what happens. Okay, that's experimental. Now, I told you, very first day of class, it's hard to lie with statistics, or so I said, very bottom, I said, it's easy to lie with statistics, and I actually crossed it out and said, that's a lie. It's not. It's very hard to lie with statistics. I go, the problem is, most people are just stupid. Okay? Well, there's that. And then there's this. Right here, different types of sampling techniques. This is usually where, and I'm gonna say it, even people with a doctorate degree get it wrong. Okay? They don't do the right type of sample, and so therefore automatically everything they've got now is, I hate to say it, wrong. It doesn't matter what they do. They go, man, I just cured cancer. Did you? You sure? You know, that's what you guys are looking at. So we're gonna look at some different types of sampling techniques. I'll give you what I think is the best one, and then we'll kind of go through them really quick. This is on and on your homework, that's how it's gonna be really. Hey, it's gonna give you a scenario. What sampling technique is it? Okay, now mind you, after chapter 2, we're not gonna be worried too much about samples and stuff like that, but it will say this kind of stuff, you know, in your questions, like later on, it'll say, in an observational study, or in this type of study. And I may just randomly say, hey, what does that mean again? What type of data is this? Because I want you to walk out of this class, remember, with concepts, more concept than math. I want you to hear them say something on the news, on social media, or your parents, or old dudes at coffee like I do a lot, because I go drink with these really old guys for coffee. It's an old guy thing. I think you're supposed to do it, I guess. They will say things like so wrong. And I'm like, did you Google that? And they go, why would I Google it? I know how to do this. I'm like, Google it, bro. You need to Google that. You have a phone. It could get you to the moon if I could hook it to a rocket. I promise you. Okay, so let's look. Here's my population. As we all know now, populations don't have to be really large, right? You're a population, okay? In this population, the first type of sample we're going to look at here is going to be called a simple random sample. Ding, ding, ding. I think it's the best sample there is. I think it's the best technique, okay? And here's how you do it. Number everybody in the population. And then you can either do it on your phone, Or you can have a computer program do it, but you're gonna have it just randomly choose numbers. Do not try to think you're random. I can prove to you mathematically, you are not random. You can literally sit here and think right now, I'm gonna start randomly picking numbers from 1 to 100. It's been mathematically proven that 31 and 7 are the most picked numbers. If that was the case, notice you're not random. Okay, so you're not, let a computer do it. Computers can be random. So what you're gonna do is you're gonna number everybody, you run your deal, and then bam, there. Randomly, those are gonna be my people I pick out. And those are the people I study in that population. So simple random sample, number them, random, draw them out. Okay, and then it gets rid of any biases. Said this yesterday, and you thought I'd like slap people across the face. I'm not, and I'm glad it's getting this on film, so use it against me. But let's pretend like I'm like an inward racist, but I'm adopted. Do you think there might be some bias? This gets rid of that. I can't control, no matter what biases I have, or if I really want my drug study to work, doesn't that get rid of some biases if I can't control who I give my pill to? Yeah, I don't even know who's gonna, the computer's gonna pick it out. So that kind of helps out. That gets rid of things. Another type, stratify, divide into like groups. Okay, boom, there's my like groups. I got dark tops, dark bottoms. That's how I decided to, group my people. Now, what they'll sometimes do in the real world, okay, they may go by zip code. Like this zip code. Like in New Mexico, if I want to do a study in New Mexico, maybe I do it over like different zip code areas, okay? Once you get them divided, once again, number everybody, okay? This group gets numbered, this group gets numbered. Once again, you run your random sample, and then what's gonna happen? Bam. Out of each group, I'm picking random people again. Okay? This one has its advantages, but it also has its disadvantages. Do you think people live differently in Albuquerque than they do here? Obviously. What if that's one of the samples? And then what if another sample is Santa Fe? And then we're the third sample? Things might be skewed. Notice how that kind of works a little bit. So even then, even sometimes what they'll do on these is they'll take a stratified sample, find them, and then they'll stratify again once they get, like if it's a larger area, okay? Go back to the population again. Then we got cluster. Cluster says this. I'm just gonna start separating people into, I'm not gonna say like things, but if I was gonna study Hobbes, maybe I would go by blocks. Like between this block and this block, here's my people. This block and this block, here's my people. Then once again, you number them. And then you run a random sample. Do not think you're random. Let a computer do it. Okay? Even though this was just 1 through 9, let a computer pick your randomness for you. Okay? Because you're going to see later on, everything you do, someone else better be able to do. Okay? And that's the problem inherent, that where you hear people say things online, go, I was reading a study. Okay, great. How many people replicated that study? Because I can go do a study right now that says every single one of you are gonna fail. And then all of a sudden, all you pass. But I can still publish that study. And unless somebody comes in, they'd be like, oh, looks like it happened. So notice there's no sort of like checks and balances. I think we got one more. Yeah, we got it. Systematic. This one's pretty good. I'll be honest. It would kind of be my number 2. Once again, I've numbered everybody, but then I'm choosing every 4th person. Okay, that works out really, really good. Why would this work bad right now? Think about it. What would be the problem? Let's say I used y'all. What would be the problem with that? Do you see a disadvantage? Are y'all all friends, more or less? Are you sitting by a friend? Hopefully. Okay. Well, what if I said pick every 3rd person and I have a group of 4 people sitting together who are all friends? Well, the 1st and the 3rd person are now going to be friends and they're going to have a common shared belief system. And so therefore, there's some inherent groups that could happen if I started trying to do every fourth person. And they might be there and I don't see them and I don't know it. And so you've got some inherent biases in there that you don't even know are there. So that's why this can be kind of a hard one to do. The other hard one to do is this one is the same thing with the simple random sampling, is you kind of got to know the whole population. Okay, you know, and that can get hard. Like for y'all, it's very easy. I've got a roll. Okay, the college, I've got a roll. But everybody in Hobbs, everybody, you think everybody's listed somewhere? That's impossible. There are some people here who are not listed anywhere. Okay, so it can get a little hard sometimes. So you do the best you can. And then the last one, I call this the stats guy. This is the one people try to do a lot. One, this is called a convenience sample. He's only going to take a sample of people near him. The reason it works really well sometimes is the stat guy, me, is trying on a different deodorant. Hey, is it working? Notice how I only did a convenience sample because I don't care about the back. You're never going to smell me, but they are. So these are the people I'm going to sample. Okay. But where it would be bad is this. What if I have another stats class that's only got like 10 people? Okay. What if I decide to run a sample of them and say, hey, should I just do this class as, let's just give one test. If you pass the whole class. If you fail the whole class. Is that fair? Why? It's convenient for me. It's easy. I don't have to talk to all of y'all. I only have to worry about like 5 or 6 students. Notice how that's not fair. I conveniently just did something easy for myself, but it's affecting a lot of people. So that's where the convenience sample can kind of maybe not want to do it sometimes. Okay. There you go. Different types of observational studies, cross-sectional study, data is collected at a single point in time, longitudinal study, data is gathered following a particular group over a period of time. Those you hear about a lot. If you're into working out, those are the kind you're hearing about right there. We gave this group of people creatine, did it work? We put them on this diet, did it work? Okay, you're not going to just give somebody food one time and go, did this diet work today? No, I want to see if it works over the long haul, right? That's how we're going to look at it. Meta-analysis, I've done these because they're really, really hard to do, but I don't have to get out of my desk. All it is I decide to take a bunch of studies, pull them together, and then see what's happening. So let's say I'm doing a weightlifting study. I want to see something about weightlifting. I'm going to go ask the question, what I want to study, and then it's going to say, well, let's go pick out studies that other people did. I'm going to draw all that information in together, and then I'm going to make my own conclusion and say, hey, guess what? Everybody keeps saying that you got to have protein within like 15 minutes after you work out, you're going to lose muscle. Oh, look, all this data that I pulled together, it's crap. That's a lie. That's just bro science. Here's my evidence. It kind of makes sense. So I'm just taking a lot of studies and putting them together. Case study looks at multiple variables that affect a single event. I talked about this one. Case studies you usually see, like with police, they do a case study. They're doing a case, right? They're still collecting data. But I would do the same thing as a statistician. I would come in and go, I'm doing a case study over a lady who got convicted of killing her kids because some guy decided to do some bad math and he convicted her. She got sent to prison. She got out and killed herself because everybody called her a baby killer. Come to find out, guy just did bad math and he went, oops, sorry. Okay, yeah, but he affected people's lives because of bad math. That's a case study. Somebody coming in me like me going, where was the failing? What happened? And that's how they caught the bad math and she got set free. Unfortunately, just like in Hobbs, guess what? You get convicted doing something bad. I say convicted, you get arrested for doing something bad. Where do they put you? Front page of the paper. You get found innocent, where do they put you? Is there ever an apology? So no, now everybody's gonna look at you the rest of your life. Hey, there's that guy or girl that did this. They don't ever put you back on the front page of the paper doing this. You know, they got you in your mugshot. Okay. Experimental studies, cause and effect relationships. Okay. Got treatment, subjects, participants, response variable, and explanatory variable. These are very straightforward, very simple, super simple. You can kind of read them there. Response variable, hey, college algebra students. Remember independent variables? Got X and Y, your X is always your independent, your Y is always your dependent, same thing. Okay? Response variable is your dependent, okay? Explanatory is the variable that causes the change. If I change X, what happens to Y? Right? Same thing. Think of it the same way, okay? So X is your explanatory, Y is your response, or you can think of explanatory as independent, response as dependent, okay? If I give you more drugs, what's gonna happen, right? If I change the amount of calories, what's gonna happen? I'm nudging one thing to see something else happen, okay? That's kind of what that means. So let's define experiment. First thing you're going to do is you're going to want to randomize the control and treatment groups, okay? Because you can't just run an experiment and just hope it works and think where you can remember things. You're going to have a control group. Control for outside effects on response variable, okay? Think about it. If I'm going to test my new diet on you, what's something I really need to make sure I control? How about the food you eat? I can't be saying, hey, I'm gonna put you on this diet, see if it works, and all of a sudden I find you out the Krispy Kreme. Because I'm gonna be like, hey, my diet doesn't work. Or find out that the day I put you on the diet, you decide to join the gym. Notice I've got to control the variables, okay? I want to see if this thing works, so I've got to control things as much as legally possible, okay? And then replicate the experiment a significant number of times to see meaningful patterns. There is a meme going around, and I see it, and it pisses me off just about as bad as the PEMDAS things that I see pop up on Facebook. You ever see those little PEMDAS? And then nobody saw. There is a math teacher in this town that I have caught online doing wrong PEMDAS, and I'm just like, oh, this lady teaches. Okay. Anyways, the meme goes this way. It shows Einstein sitting there, and it says, when I came up with the theory of gravity, they said, or some theory, I don't think it was gravity, they said that we found 10,000 researchers that were against it. They wrote papers. And he said, if it was wrong, one would be enough. Wrong. Einstein never said that. And that's a lie. Okay? That's exactly how research has worked. I design something. I say, my thing worked. Here it is. Okay? And then other scientists take my data and go, can we do this the same way he did it and get the same results? And if we can, it seems true. Do you genuinely want me to publish a study that I found out that if you drink bleach, it's going to cure cancer? And nobody tests that? First off, they should be going, first off, that's a lie. We know this is what bleach does. No, you don't want that. Okay? People be publishing anything they wanted. No, things have to be replicated a lot. Okay? That sort of goes to my little debunking thing I told you in your head. When you hear somebody say on TikTok or whatever, go, I read a study that said using tea tree oil is going to help you get 20/20 vision. That's awesome. How many studies say that's crap? You ever ask yourself that? No, you just hear some guy you like say something, but you don't realize there's a whole bunch of other people behind him going, no, don't do that. That doesn't work. It's never worked. We know it doesn't work. Okay? So do that. Ask questions. Control group, like I talked about. A control group is a group of subjects to which no treatment is applied in an experiment. I'm going to have some people use my diet. I'm going to have other people not. Right? So I can kind of see what happens. Okay? A treatment group is a group of subjects to which researchers apply treatment in an experiment. Confounding variables are factors that the other treatment that cause an effect on the subject of an experiment. Here's the problem. You see the slide up here? I got one control group. They're just going to do a study, right? They're just in there working like normal, like what you're doing. The other one's got, 4 or 5 piece band. An unknown variable in that would probably maybe be is, can everybody hear? Or maybe you're one of those type of people that likes loud music playing. I've walked into places like me, I can't. I have these binaural beats whenever I'm studying or something, there's a whoa, whoa, whoa kind of thing. That's what I like. But my wife can watch, dude, a Marvel movie, the kids in there playing, and she'd be there studying away. And I'm like, oh, I can't do that. Those are confounding variables. So you got to look at kind of stuff like that. Okay. Okay, this video is going to play. I don't know if the audio is going to work, but we'll find out.
Ever hurt yourself as a child and had someone kiss it better? Did it work? If so, you experienced the placebo effect. The kiss didn't actually do anything, but because you believed it did, it made you feel better. While this might be great for moms and dads, it's not so great for doctors. Because when we're trying to test a potential new drug in a clinical study, the placebo effect can cloud our results. It happens like this. To study the effects of an investigational drug, we may give one group of people the investigational drug and another a placebo. They won't know which. Both look the same and are taken in the same way, but the placebo contains no active drug. So in theory, any differences seen between the two groups should happen as a direct result of taking the investigational drug. But it doesn't quite work that way. Because people want to get better so badly, they can actually fool themselves into thinking they are taking the investigational drug, and that it definitely works. This can result in people feeling better despite being in the placebo group. It can also amplify any effects seen in the investigational drug group. That is, their high expectations of the investigational drug can make it seem like the investigational drug is working better than it actually is. This sounds great, but the problem is that these results are false. They give study doctors the wrong idea, and this could lead to people being given treatments that don't work in the way we expect. We can do our bit to minimize the risk of the placebo effect, but we rely on you doing your bit too. For example, it can be tempting to tell other study participants about how you are feeling, but it's really important not to do this because it could change the outcome of the study. Why? Well, because telling someone that you feel better or worse could influence how you feel. And if you are talking to another study participant, it could influence how they feel too, even if they're taking a placebo. Clinical studies are at the heart of all medical advances, and so it's very important we get them right. New treatments under study may be better than standard treatments, or they may be worse. And so even if you're taking the investigational drug, there's no guarantee you'll get better. That's why we have clinical studies after all, to find out.
You know about the placebos? You ever heard about that before? We're all affected by it. Once upon a time, ladies would take birth control pills. I don't know exactly how they do it anymore. But they weren't all the pill. They would have sugar pills in there. And the lady wouldn't know which one is what. Okay? Kind of weird, but the body would know, hey, I took a pill, I'm good. Okay? Now, it doesn't mean they could just be given all sugar pills. Okay? But it happens more than you know about placebos and stuff like that. And it's hard to account for. It really is. It's something you got to be careful of. Not throwing it under the bus, or however you feel about this on either end of the spectrum. We saw it happen a lot during COVID, especially during some of the trials. I'm not saying the vaccine is good or bad. I'm not going to go that direction. But people were so tired of being sick, what'd they do? I'm going to give you a shot. And what did they do? Feel better. Did it really work? I don't know. I'm not going to say they don't work. I'm not going to say they do. But man, we were pretty much ready to take anything, weren't we? To get back to normal. You know? So, did they work? Did they not? More studies need to happen. And there were actual studies that happened, but think about it. People were giving people anything. I could have gave you a glass of water and said, hey, this is going to cure COVID. They'd be like, am I going to get to go to the store again? You know, so think about that kind of stuff. Okay? No. Let's see. All right, last thing, in a single blind experiment, subjects do not know if they are in the control or treatment group. But the people interacting with the subjects in the experiment know in which group each subject has been placed. In a double blind experiment, neither the subjects nor the people interacting with the subjects know to which group each subjects belong. Which do you think is better? What do y'all think? Single or double?
Single.
Single? So it's better for the doctor to know who's getting what. Okay. I really want my cancer drug to work. I really do, because man, I'd win a Nobel Prize. And I know that it doesn't work on dark-skinned males with dark hair very well. But it works really well on light-skinned, dark-haired females. Who do you think I'm gonna give the drug to? Okay, whereas if someone just hands me a box of pills, now it's my study, but they hand me a box of pills and I don't know who's getting what, then I can start saying, hey, look what's happening. So really a double blind is better, because you really don't want the researcher knowing who's getting what either, because as you'll see in the next PowerPoint I'll show you, everybody has biases. I'm sorry. If you're trying to cure cancer, even if it's you want to cure cancer, that's it. And you're going to tell people, dude, I'm doing it for free. I don't want any money. I think the guy that cured polio, he gave it away for free. He made zero money off of it. Okay? Or measles, one of the two. Still, don't you think he has some biases? Yeah, he wants to cure you. He wants it to work. That in and of itself, even though it's a good bias, still a bias. Okay, and therefore can take you down the wrong road. So it's good to have that another level of, hey, let's make sure this is really working. That's why we take proper samples. That's why we understand how to classify data. That's why we make sure to do these studies. That's why we make sure to design the studies a certain way. You notice how hard it is now to lie with statistics, but there's a lot of areas in there that people can get lazy. And then that's where bad stats come from. It's stupidity, lazy, and lack of understanding, and even bad math. But there was nothing really ever nefarious. It's literally just a breakdown of some stuff. Maybe lack of money at time, like, hey, you're gonna do this great study, but we don't really have the money to do this type of sample. Let's do this one. Well, then don't do it. Wait for the money. Do a proper sample. That kind of makes sense? Okay. Give me 1 second, I gotta stop sharing to go back to the other screen real quick. See if it's gonna work here. Shared meeting. And well. There. Very quickly, we'll go through this one. It's the last one for the day. How to critique a published study. If you don't listen to anything else today, maybe this is the thing you should listen to. So maybe this will be something whenever you hear someone, be it a parent, me, your preacher, okay, anybody. If you go to church, they say be Berean. Okay, that means what it means when Paul would be speaking, okay, the Bereans would go, what do you say? And they'd run back and go, yeah, okay, it's there. I believe it. Yeah, I see it. You need to do the same thing. So when you read a study, go read it and read it correctly. Okay. So this is how to read one. How to critique a published study. 1, consider the source. Man, I really want you to know that salt's bad for you, says the sugar company paying for the study. Look who funded it. You'd be surprised. How many of y'all read an article online and see who paid for the article? Oh. You'd be surprised. Scroll to the bottom. See who paid for it. I wanted to talk crap. Biden's got dementia. Paid for by Republican Party. Trump's a philanderer. Paid for by Democratic Party. Consider the source. And I say published study, that counts as articles. Okay? 95, they're calling it the dead internet theory. Y'all heard that? That the internet's dead? Because humans don't write it anymore. Everything's AI generated. But they'll tell you, this study was done by an AI. I don't want an AI doing it. Trust me, I'd catch ChatGPT like crazy. Okay? So think about it. Consider the source. Consider the variables. I'm not gonna study how well people hear at a deaf school. It sounds mean to say it that way, but it has happened where people find people with a disability and then do a study over those people. Like, I really want to test to see if my weightlifting drug works. Why don't I test 18-year-old high testosterone boys? Oh, look, it works great. Yeah, let's think of the variables in there. My drug's not working. I have picked who I want. Or even on the flip side of that, variables. Hey, my sleep drug isn't working. That person just lost their mom. Okay, there's other variables at play, and you need to find a way to control those as much as possible. Okay, when thinking about that. And when you're reading it, they have to list them. Okay, like, and that's what makes studies hard, is I have to go, hey, I did this study over what causes math anxiety. I did a meta-analysis about 2 years ago. What causes math anxiety? I found that it was early, middle school, and elementary school teachers and parents. Okay, well, what would be the confounding variables? Well, also lack of studying of the student. That's a variable. Like, were the students with math anxiety, were they the students who actually wanted to do homework, they wanted to be good? Or were they the ones like, I just don't do my homework? That's a variable that you have to account for. Okay. Consider the setup. What does that mean? Well, sampling bias. Once again, I didn't choose the right sample. Maybe I want to test on how well is my use of dropout detective that we use gonna work, and I'm just gonna focus on you. That's stupid, because you're in an upper level math class, you've already been in college a while, the chances of you dropping out are pretty slim to none. Now compare that to a beginning class, very brand new at college. Oh, now it's gonna look a little different, isn't it? Okay, so I need to consider how I'm doing my sample. How did they do their sample? Dropouts happens a lot. When people design a study, they sometimes will pay you for one thing. So if you need extra money, look up. They have sites online that say, hey, we'll pay you to be part of this study. But then people will take the money and just run. Well, they have to account for that. That's going to affect the study, because I was planning on this many people and then some people dropped out. That has changed that's changed things for me. Okay. Processing errors. Once again, bad math. You'd be surprised how many times some very large things are ran by like Excel and someone put the wrong number in. Changes everything. Okay. You've understood this, because how many of y'all have forgot the negative? Okay, there you go. Non-adherence. It's basically this. I'm doing a study. I'm going to use weightlifting again. And I'm going to tell them, hey, this is exactly what I want you to do. This is the workouts I want you to do. This is the food I want you to eat, whatever. And they're like, gotcha. They go home, we're actually in the butt. I'm going to use some testosterone as well, but I'm going to stick to what you're doing, but I'm going to use some other stuff. They're not doing what I told them to do. You've got to do exactly what I want. They're not adherents. They're sticking around for the study, but they're not doing what I said. Kind of makes sense? Okay. Research bias. I really want it to work. So please, 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 I hope it works. So that's the researcher bias. I really hope it works. So I'm only going to study this group of people. So I'm only going to sample these because it's going to look really good. Okay. Response bias. Believe it or not, people will lie. They'll say the drug's working because they want to make the researcher happy. Okay. Maybe it's a guy and it's a really cute researcher. He's like, oh, I don't want her to be mad at me. So, hey, or vice versa with a girl. Okay. They'll say stupidly, oh, it works great. All the while, like, it's not working at all. Participation's bias. Okay. That one doesn't happen as much, but sometimes participation bias is sort of like, I only want to do and get these type of people just because I like them better. Okay, there's no real inherent like implicit bias, but maybe I'm like, I don't want to have to do this kind of study. I can just do this. It really kind of goes in that kind of vein. And then non-response bias. I do everything. You see this a lot. I'm a part of that. Okay. Anybody here over 18? Okay. Did you get the text messages during the deal saying, hey, do this poll and see who you'd vote for? Did you get, yeah. Did you answer those? Congratulations, you're a non-response bias. Me too. I didn't answer those because I'm like, why are you texting me? That's stupid. I'm not gonna, I didn't. And usually, did you click stop or did you just forget about it and just erase the text?
Just delete it. Right?
Yeah, see, next thing you know, a week later, you're getting it again. Yeah, but that's a non-response. Okay, we didn't choose to be in that study. We got kind of chosen, okay? But still, it's a non-response. I chose not to respond. Sometimes people will be part of these medical things and then all of a sudden they just don't answer. They did it, they don't answer. Read this very quickly. Dihydrogen monoxide is a colorless, odorless, tasteless, and kills uncounted thousands of people every year. Most of the deaths are caused by accidental inhalation of DHMO. You can read the dangers. That's very, very bad. Prolonged exposure causes severe tissue damage. Okay, contamination is reaching epidemic proportions. Quantities of dihydrogen monoxide have been found in almost every strain. Would you ban this substance if you read this study? Does it sound horrible?
Yeah.
Yeah. You would ban it? You just banned water. That's what you just banned. Read a study carefully, okay? This study right here, if you ever want to feel stupid, this was done by an 11-year-old girl, okay, for her science fair project. And it stumped everybody. She had a petition signed. Yes, we're gonna ban this. And she was telling me, yeah, you're banning water. But notice how me changing the words around makes people afraid. Okay, and that's a study. She did it. And her study was, I believe it was called, how gullible we are. An 11-year-old girl found out how stupid people are. And we all are. We all fall for things all the time. Because what did they not do? Did they ask any questions? What is dihydrogen monoxide? What does it look like? I don't know. Di-2 hydrogen H, so H2 mono 1 oxide oxygen. Oh, H2O. That sounds a lot like water. So no, it's just asking yourself questions. Why is it causing tissue damage? Because I hit you with a block of ice, or you get frozen by it, it's gonna hurt. There you go. Good so far? So once again, and then consider the conclusions, and that's the last slide. Consider, what is it saying? What kind of thing is it telling you? What did this study tell you? Does it make sense? If I'm studying the effects of car buying on middle of the road women, but then I give you the answers about men, does that make any sense? No. Make sure everything is congruent all the way. All right, now, before you leave, do not walk out of here, just that correct? You need to be on Hops. As of next week, remember these words. I will start taking off points if you're not in Hops. And I don't see you in Hops because I will be starting to an official attendance grade, which means using that QR code over there. So make sure it's working for you. You can do it today, make sure it's working. But after that, you're gonna need to be in Hops. You're gonna start getting emails and then I start taking off on yourself and community and your communication grade. You also need to make sure that I'd get ahead on homework. Right now, homework is super, super simple. I promise you, you can get all the homework done in literally probably like, worst case scenario, an hour. Okay, from 1 and 2, it is mind-numbingly easy. Okay, the real math starts on chapter 3. You need to make sure that you have your TI-83 or TI-84 calculator. Somebody, maybe in this class, asked about TI-89. It might work, it might not. You'll find out real quick. Okay, so have a great day and I will see